Alright, this video is on displaying and analyzing categorical data. And we're going to move fairly quick. You are probably not going to do too much with categorical data and their graphs in general. At most, it would be look at a categorical data graph and maybe talk about it. So we'll move relatively quickly through these. But a frequency table is simply when you're making a table where you list each different category there is. So if we're talking about like what's the highest degree held by a CEO, we list all the different values you can have for that categorical variable, and then we just count how many people are in each of those groups. And then sometimes you list the total, that total is the 40 people. A relative frequency table is simply when you do the same thing, you just divide by the total and turn everything into 2%. So again, I mentioned this in another video, but frequency is a count of how many there are. Relative frequency is calculating the percentage of how many there are. Another type of display that's more of an actual graph would be a bar graph. Each bar represents a different category. So on the graph on the left, here each bar is a type of fruit. And in the graph on the right, each bar represents a different color. That's somebody's favorite color. One of the conventions for bar graphs is that bars should be separated. That's kind of a way to separate this from a histogram, which is a quantitative type of graph. Also, I just have this note here. Be careful when you draw conclusions about relative frequency bar graphs, or really even frequency bar graphs. When we make a bar graph, since these bars are categories, the order doesn't matter. It doesn't matter which one's on the left or the right. So you need to be careful to not make any statements like, oh, as we move to the right in this graph, the height of the bars gets lower. That type of statement with a quantitative graph, with something called a histogram we might make, because there in a histogram, the order of the bars never changes. But we could have made this same graph and had blue be on the right side or blue be somewhere in the middle. So we need to be a little bit careful when we draw conclusions about relative frequency bar graphs. We also have to be careful about, when you're talking about relative frequency, that relative frequency is just a percentage. So we need to be careful, depending on how the graph is set up, drawing conclusions about how many people, if all we have a graph for is a percentage. Pie charts, another common type of categorical graph, although we generally don't make them by hand. They're really great like in Excel and computer programs, but they're kind of a pain to actually in detail draw up by hand. If you were to ever make one, it would be totally fine to just roughly sketch it. Just make sure that your approximate size is right. So like if this piece of pie is supposed to be 44%, make sure it's not bigger than half a circle. Make sure it is bigger than a quarter of a circle. So make sure its rough size is right, and that's good enough. One of the things we need to maybe think about would be, if they gave you a certain type of graph, could you make a pie chart from that graph? So here are two bar graphs. If they want to know, could we make a pie chart out of the following graphs? The key is to make a pie chart, you need to have the percentages for every slice of the pie. Or another way to think of it is, you need to have the data for the entire group, or the whole total. So if we look at this one on the left, and we start looking at these percentages, here we have 55, 30, 30, 15. We have way more than 100%. And that's because the data in this graph didn't come all from one group. It came from several different age groups. So for this one on the left, we could not make a pie chart out of this. The one on the right, however, they went and asked a bunch of people who were buying a new Apple computer what their previous computer was. And here we do have a graph that has everybody they asked. It adds up to 100% if you added the 3 bars. So we could convert this into a pie chart if we wanted to. Now, some general words of warning about graphs. And I point these out not because you're going to necessarily have to make a lot of graphs, but they have directly asked questions about these kinds of flaws in graphs. And also they have put like incorrect choices where the reason they're incorrect is because of some of these issues. First, generally your y-axis in a bar graph should start at 0. And the reason is if you were to look at this graph on the right that starts at 10, you might say, oh, almost nobody ordered a PC. Now, PC is definitely the smallest, but if we look at the real correct graph where the scale goes to 0, it's definitely not nearly as close to 0 as this one visually makes it seem. So your y-axis should always start at 0. Be careful when using images or icons for counts. Sometimes you like to do this to kind of like spice up the graph and make it look a little more visually appealing. But the problem here is with these icons is it kind of makes it hard to read the graph. For this computer, am I supposed to follow like the angle of this screen and say that about 300 people bought a Macintosh? Or does it come straight across? And then visually, let's say it goes, I think it is supposed to be straight across. So this is around 250. This smallest one, the Windows one, is around, I don't know, maybe 60, 70. But it's, so 250 down to, let's say 50. This should only be 5 times as big. But if you actually look at the physical size, based on the size of that icon, this is really like 12 times the area. So the physical size, again, if you're just glancing at a graph, makes it seem like there's a much bigger difference between this and these other two, just because of the way that picture is drawn. Next, make sure you label axes with the scale of the graph. This is from the 2016 election, but they kind of just threw up these bars in the background. And if you don't really look close at the numbers, it makes it seem like this is 0, and look at how much bigger this bar is than that bar. But if you actually draw it to scale, the physical distance between the two that they drew, this would only be at 33.7%. So if you're going to draw it to scale, those two should be much closer. So we need to make sure to label the axes and tell where the scale is on the side so we can properly compare the things that we're looking at. And then also double check accuracy using the axes and the scale of the graph. So this is the unemployment rate under President Obama. To be honest, this one has a whole bunch of problems. So I'll just pause it and look at this graph and see what you notice. Let's start looking through these. First of all, if you look at where 9% is, and that does seem to be right across from 9%, but if we trace this over here at the exact same height, is 9% again, cool, but then 8.6%, which is 0.4% lower. That's the most significant, or one of the most significant changes in the graph. Here's 8.8 and 9.2, that should be the same difference, and here it's totally flat. Also, the lowest point in the graph here is 8.8%, but it should be at the end of the year, at the end of this graph, when this dropped way lower. So this one has all sorts of issues around how it's drawn, but double check your accuracy with your axes and your scale to make sure where you're putting dots and where you're connecting things matches up correctly.